Prove that for all positive real numbers b, x, and y with b not equal to 1, that log base b of x over y equals log base b of x minus log base b of y. Now, I haven't checked the solution, so I'm sure there's probably an easier way of doing this. But the way I tried to do this is I ended up setting both of these equal to different letters. So let's start with the left-hand side. Log base b of x over y, we're going to say equals some letter L, capital L. And then we're going to separately have another equation here, log base b of x minus log base b of y equals some capital letter K. The goal here really is to show that L and K are the same. If we can show that L and K are the same, then we're done. But this gives us two equations that we can work with separately here. So let's start with this blue equation, and what I'm going to do is I'm going to change it into exponential format. So instead of log base b of x over y equals L, we can write this as b to the L equals x over y. We'll come back to this equation here. Let's move on to the red equation. For the red equation, I'm going to solve for log base b of x by moving this log base b of y to the other side. So this says log base b of x equals capital K plus log base b of y. And then we can convert this into an exponential format. Now keep in mind, I'm focusing on specifically this log, not the other log. I'm turning this log into exponential format here. So this is going to be b to the k plus log base b of y power. So this exponent is going to be a little messy here, but this will be k plus log base b of y. And this whole thing equals x. Now this can be simplified by the law of exponents. We can split up this exponent with multiplication. So this is b to the k times b to the log base b of y equals x. B to the log base b cancel. And so we're left with k times y equals x. And so b to the k equals x over y. And here's the other equation that we need. And we're going to use these two equations and compare them because if you notice, they both equal x over y. And so they must both therefore be equal to each other. B to the L must be the same as b to the k. But in order for these to be the same, where b is not equal to 1, that's really important here because if b was equal to 1, then L and K could be anything, and this would be true. But since b does not equal 1, that means that these exponents have to be the same. L has to equal K. And since L equals K, then that means these two values must be equal as well. And that proves the property. The most common mistake I see students make with this problem is that I see a lot of students use this equation to prove this equation. And that's called circular reasoning. You're not allowed to use the thing that you're trying to prove the thing that you're trying to prove. That doesn't make any sense. So it's really important that you don't use this equation to solve for anything. You can't use this equation at all. You have to derive the equation, which is why I started by setting the left side equal to something and the right side equal to something, just to separate these two things. I don't want to assume that they're not separate, because then that would be possibly assuming the conclusion. Thanks everyone, and I'll see you in the next video.